So this is another section lifted directly from my Math 114 class. It's the part B of the section 2.2. It's actually section 3.2 in Math 114, but that doesn't matter. This section is mostly on parallel and perpendicular lines. Again, should be a review, so I'll go through it lightly. So parallel lines, they never meet, they don't intersect, they're always the same distance apart. Parallel lines have exactly the same or equal slopes. Specifically, if M1 is the slope of one line, we'll call it line 1, and M sub 2 is the slope of another line, we'll call it line 2, if the lines are parallel, then the slopes are equal. This is a fancy symbolic way to say parallel lines have the same slope. Also, vertical lines, different vertical lines are parallel to each other, and they don't really have the same slope per se because they have undefined slopes. For what it's worth, let's just jump into this work down here. So here I gave the line y equals 1/2 x plus 5 and y equals 1/2 x plus 1. Each of these lines is written in y equals mx plus b form. It's solved for y. When an equation of a line is solved for y, we say it's in slope-intercept form. And we know that for each one of these lines, that the slope is the number in front of the x. So for the line y equals 1/2 x plus 5, the slope is 1/2. For the line y equals 1/2 x plus 1, the slope is 1/2. This means these lines, if I graph them, are going to be parallel because parallel lines have equal slopes or the same slope. So down here, I took the time and graphed these. I actually probably lifted this off of Google Images. Here's the graph of y equals 1/2 x plus 5. Here's the graph of y equals 1/2 x plus 1. They both have a slope of 1/2. You see they're perfectly parallel. This is an example of parallel lines. They go in the same direction. They never cross each other. Because of the undefinedness of the slope of vertical lines, I make a little extra lecture for vertical lines. So if I gave you the line x equals -2 and the equation of a line x equal to 4, because both of these equations only have x's, I know the graph is going to be a vertical line. This is going to be a vertical line that goes through -2. This is going to be a vertical line that goes through 4. Vertical lines are parallel to each other. Here's the line x equals -2. It goes through -2 on the x-axis. It's parallel to the y-axis. Here's the graph of x equal to 4. It goes through 4 on the x-axis. It's parallel to the y-axis. These graphs are parallel to each other because they're vertical. Technically, I guess you could say they have the same slope because they both have undefined slope, but it's not really a number. This is why we usually separate the x-equal lines when we're talking about parallel lines. Parallel lines are easier than perpendicular lines. It's easier to draw parallel lines. It's easier to see lines are parallel. Perpendicular lines meet at a 90-degree angle, and with my graphing ability, it's pretty darn hard for me to graph a line and make you believe that it's perpendicular, especially because the window somehow could distort how the line looks. When they're really supposed to be perpendicular, it may not look perpendicular. So perpendicular lines, I have to kind of take a little leap of faith sometimes to believe lines are perpendicular from the theory. So anyways, perpendicular lines meet at a 90-degree angle. So this is the 90-degree angle right there. There's a vertical and a horizontal line meeting, and those lines meet at a 90-degree angle. That's what it means for lines to be perpendicular. Where the lines cross, they form a right angle. The tricky part of perpendicular lines is how the slopes compare. Parallel lines, the slopes are 100% equal. Slopes of perpendicular lines, we say, are negative reciprocals. For instance, if the slope of one line is 3/2, then the slope of the line perpendicular to it, it has to be the reciprocal with the opposite sign. So if I know the slope of one line, and I want to know the slope of a line that's perpendicular, slopes of perpendicular lines are reciprocals with opposite signs. So if a line has a slope of 3/2, then a perpendicular line, I'll go m perpendicular, this little upside down t means perpendicular, the slope of a perpendicular line would be negative 2/3. Or if I gave you a line like m has a slope of negative 3/4, then the slope of a perpendicular line with a little subscripted upside t down t mean perpendicular, the slope of the perpendicular line would be the reciprocal with the opposite sign. The reciprocal of negative 3/4 would be positive negative 4/3, but I need to flip the sign. So slopes of perpendicular lines are reciprocals with opposite signs. If you want to, if you can multiply the slopes of those lines, you get -1. If I multiply 3/2 times negative 2/3, if you take the slope of two perpendicular lines like 3/2 and negative 2/3 and you multiply them, they always multiply out to be -1. Similarly, for that set of perpendicular lines, that slope of negative 3/4 times the slope of the perpendicular line 4/3 multiplies to be -1. It's not that big of a deal, but it's a fact. Perpendicular lines have slopes that are reciprocals with opposite signs. And again, when you start dealing with undefined slopes, it's kind of hard to talk about reciprocals. I don't know what the reciprocal of undefined is. So verticals and horizontal lines are always perpendicular to each other. I did another example here. I have the line y equals 3/4 x plus 5. I graphed it here in this orangey color. That line has a slope of positive 3/4. And then the line negative 4/3 x minus 6, I graphed in blue, has a slope of negative 4/3. These two lines the graphs of these two lines should meet at a right angle. They should be perpendicular because their slopes are reciprocals with opposite signs. And I don't know how that looks like that looks like a 90-degree angle, but that is supposed to be a 90-degree angle. The best I could, getting the window to fit here. Sometimes when you start distorting the window, it tweaks the angle a little bit. But if lines have slopes that are reciprocals with opposite signs, they're perpendicular. Here I did a y equal line and an x equal line, and they're also going to be perpendicular. And this side I graphed a vertical line, x equals 3.6. I don't know why I picked 3.6. Maybe I stole this off of Google Images. And y equal to 3 is graphed with this horizontal line. So a horizontal line, an equation that only has a y, and a vertical line, when they meet, they're going to be perpendicular. They're not technically, their slopes aren't technically reciprocals with opposite signs because you got the undefinedness of the slope. So usually when you have x equal lines mixing up into the theory, we usually carve out a little option for those. So the first group of problems between 35 and 46 are three parts. Find the slope of the given line, find the slope of all lines that are parallel to the given line, and find the slope of all lines that are perpendicular to the given line. Super easy. Problem 36, if I want to find the slope of the given line, because the equation is solved for y, the number in front of the x is the slope. So the answer to 36a, the slope of the given line is -2/7. When I go on to part B, find the slope of all lines parallel to the given line. Parallel lines have exactly the same slope. So any other line that has a slope of -2/7 is going to be parallel to this given line. Part C, find the slope of all lines perpendicular to the given line. So to find a slope of a line perpendicular to a line that has a slope of -2/7, I form the reciprocal and I change the sign. Changing the negative sign to positive, flipping the fraction, the slope of all lines perpendicular to the given line are +7/2. Same questions for 38 and 37. In 38, what's the slope of the given line? The slope of the given line is 2 because it's in y equals mx plus b form. Part B, what's the slope of any parallel line? Parallel lines have exactly the same slope, so any line that has a slope of 2 is going to be parallel to the line y equals 2x minus 3. In part C, find the slope of all perpendicular lines to the given line. Well, because the given line has a positive slope, I need to change the sign to get the slope of the perpendicular line. I also have to take the reciprocal, which means I need to think of that 2 slope as a fraction 2 over 1. The reciprocal of 2 is 1/2. So any line that has a slope of negative 1/2 is going to have a graph that's perpendicular to the y equals 2x minus 3. And I've got flexibility with this negative sign. I can write the negative out in front of the fraction, and if for whatever reason I liked it in the denominator, I could actually put the negative in the denominator. I instinctively go to one of these two. I guess I just instinctively wrote that, but this might, in times it might be more appealing, but it doesn't matter. As long as you have the fraction 1/2 with a negative somewhere, it's completely fine. 39 and 40, same questions. 40, find the slope of the given line. Because the equation is solved for y, the number in front of the x is the slope. The given line has a slope of 7/2. Find the slope of all lines parallel to the given lines. Parallel lines have the same slope, so any line that has the same slope as the given line is going to be parallel to it. And find the slope of all lines perpendicular to the given line. I find the reciprocal and I change the sign. So the slope of all lines perpendicular to the given line is negative 7/5. Yeah, I wrote too many of these problems, but they go fast. 42, find the slope of the given line. The slope of the given line is negative 4. It's a number, it's in the y equals mx plus b form. The slope is the number in front of the x. That's for part A. Part B, all parallel lines have to have that same slope of negative 4. Part C, perpendicular lines have to have a slope that's opposite sign, so it's going to be positive. And then I need to take the reciprocal, which means I need to think of the 4 as a fraction with a 1 in the denominator. The reciprocal of 4 would be 1/4. And the reciprocal of negative 4 would technically be negative 1/4, but I need to change the sign to find the slope of a perpendicular line. So all perpendicular lines, all lines perpendicular to y equals negative 4x plus 8 are going to have a slope of 1/4. Here comes the tricky problems. Anytime I'm missing a variable, it's tricky. I just got to have to logic it out. So question 44a, find the slope of a given line. This is an x equals. X equals are vertical lines. Vertical lines have undefined slope. Which means all lines parallel to this given line have the same undefined slope. And then the tricky part. To be perpendicular to a vertical line, you have to be a horizontal lines. So horizontal lines, because this line is vertical. Horizontal lines, all horizontal lines are perpendicular to the vertical line that's drawn here. Because it's a vertical line, any line that's horizontal is going to be perpendicular to that, and horizontal lines have 0 slope. So the answer to part C, find the slope of all lines perpendicular to the given line, is going to be 0. Last trick. So 46a, find the slope of the given line. It only has a y, so the slope is 0. 46b, the slope of all lines parallel to the given line is going to be 0. In 46c, I can probably actually sneak it out. If I wrote the slope as 0 and then I made it into a fraction, the slope of a perpendicular line, I need to change the sign and take the reciprocal. I'd get that fraction. That fraction has a 0 in the denominator. It's going to have slope undefined. But I should know that because this right here is a horizontal line, and I should know horizontal lines have a slope of 0, since the given line is horizontal, any vertical line, or all vertical lines, will be perpendicular to the line y equals 1. Because that line is horizontal, and any vertical line in the world will be perpendicular to the line y equals 1. And vertical lines have slopes that are undefined. Few more problems, and we'll be done with this part, and then we'll have one more section of purely lines. So, in problems 47 through 52, I give you 2 points that are on line 1, 2 points that are on line 2. I'm asked to find the slope of line 1, I'm asked to find the slope of line 2, and then examine the slopes to figure out if the lines are parallel, perpendicular, or neither. So when I go to do problem 48, I should have 3 answers. One answer is going to be the slope of line, I'm running out of room here, so I'm going to write line 2. I should say the slope of line 1 is, and then I'm going to say whether the lines are parallel, perpendicular, or neither. Let me find the slope of line 1 by subtracting the y's in the numerator, second point minus first point, the x's in the denominator, second point minus first point. The first line has a slope of 11.6. I probably didn't need to write the m, but just instinctively came out. That doesn't tell me whether the lines are parallel, perpendicular, or neither. I need to know how their slopes compare. For line 2, to find its slope, x coordinate, y coordinate of the second point minus y coordinate of the first point divided by x coordinate of the second minus x coordinate of the first. That's going to be negative 6 over 11. So the second line has a slope of negative 6 over 11. Now I can answer, are these lines parallel? No, they don't have exactly the same slopes. Are they perpendicular? Yes, they have reciprocal slopes with opposite signs. So are the lines parallel? No. Are they perpendicular? Yes. They can't be neither. They're neither if they're not parallel nor perpendicular. So my answers for question 48, slope of line 1, 11.6, slope of line 2, negative 6 over 11, these are perpendicular. Same instructions for 50. So let me find the slope of line 1. Slope of line 1 is going to be y coordinate of the second point, which is negative 8, minus the y coordinate of the first point, which is negative 2, divided by x coordinate of the second point, which is 3, minus x coordinate of the first point, which is 4. The numerator becomes negative 8 plus 2. So the numerator becomes negative 6. The denominator, 3 minus 4, is negative 1. So the slope of the first line is going to be m equals positive 6, as you get negative 6 over negative 1. The two negatives cancel out to be positive. I'll do the second line. Slope of the second line, y coordinate of the second point minus y coordinate of the first, divided by x coordinate of the second minus x coordinate of the first. This is going to be 18 over 3, which is going to be 6. Slope of the second line is also 6. Now I'll answer the question. These lines are parallel because they have exactly the same slope. Last problem. Since we've done one parallel and one perpendicular, if I was betting, I'd say this is going to be a neither, but let me do this. So let me first find the slope of the first line, which is going to be 5 minus negative 14 over negative 2 minus 7. This is going to give me 5 plus 14 in the numerator. The numerator is going to come out to 19. The denominator is going to be negative 9. So the slope of the first line going to be m equals, and I don't like the negative in the denominator. I instinctively write it in the numerator, and it can be moved around. Now I'll move on to the second line. Slope of the second line is going to be 24 minus 5 over 9 minus 0. It's going to be positive 19 over 9. This is a classic, trick to make you think something that you're not supposed to think. So are these parallel? No, they don't have exactly the same slopes. They have opposite signs. They can't be parallel. They have a chance of being perpendicular because they have opposite signs, but the slopes aren't reciprocals. It's not enough to have opposite signs. You also have to be reciprocals. So these aren't parallel. They're not perpendicular. These two lines are neither parallel nor perpendicular. So that's everything to kill off section 2.2. We'll move on to section 2.3, and that's a little bit harder, where we start finding equations of lines. So we'll stop this, but you need to really understand everything in this section 2.2 before you move on to 2.3. I'm going to assume that 2.2 is kind of, you know it before, as I go and do section 2.3.